teach some AP chemistry. We got a unit test in like a day, and I heard you got a really good grade last year.
I'll do what I can. Equilibrium is K equals the reactants over products. It's like C to the F over W.
What are you talking about?
What, dude?
What do you mean what I'm talking about?
Let me teach this to you, Cameron. The equilibrium coefficient is KEQ. That's pretty much the concentration of C to its order, and the concentration of D to its order. Same thing with A, same thing with B. Essentially, it's products over reactants, not reactants over products. Kc is for your molar concentrations. That's the constant you would use. Kp is the constant you would use for partial pressures. Ka is the constant you would use for acid dissociation. So Ka is your acid dissociation constant. Then Kb is going to be your constant for base dissociation. Kw is the ionization of water, which is always equal to 1 times 10 to the negative 14th. Ksp is a tricky one. It's solubility product, and there's never a denominator. Now, if you're given Kp or Kc, you can use this equation, which is derived from the ideal gas law, to find either or. The next page, we're learning about the reaction quotient, which is Q. You can find it the same way that you find K, or Keq, and essentially products over reactants. Now, if Q is less than K, the equilibrium shifts right. If Q is greater than K, the equilibrium shifts left. And if Q is equal to K, the reaction is at equilibrium. Now Josh is going to teach you a little bit about kinetics, Cameron.
Well, Cameron, if you didn't know anything about equilibrium, you're not going to know anything about kinetics, okay? So on this page, I'm going to show you how I would find the rate orders of A, B, and C. So on the first one, you're going to have to find out which ones cancel between the experiments. So take experiment 2 and experiment 1, okay? A cancels, B cancels, and so you'd be finding the rate order of C, right? And 0.20 divided by 0.10 is 2, and this would be 1. So 2 to the x equals 1, and so we know that that would be 0. And you would do that over and over for A and B using different experiments until you found all 3. And finally, your rate law would be K times A to whatever you find, B to whatever you find, and C, which we just found to be 0. Also, the integrated rate laws are very important in kinetics. For first order, you have ln of A final minus ln of A initial equals negative kt. It's important to note that for first order, the slope is always negative. And the half-life is 0.693 or ln of 2 over k. For second order, it's 1 over the final concentration minus 1 over the initial concentration equals kt. And opposite of first order, this is a positive slope. So in the 0 order is the rate law, rate equals k. Now I'm going to head it over to Wes.
Alright, chapter 13 is electrochemistry. The first thing in electrochemistry is just the oxidation numbers. And so from this chart you see all the alkali metals have a +1 oxidation number. The alkaline earth metals have a +2. Group 3A is +3. Oxygen is always -2. And the halogens are always -1. Big thing to remember that really helps you out when you're doing these equations is Leo says Ger. And it means lose electrons is oxidation, and then gain electrons is reduction. And this is the Gibbs free energy equation that you can use with that too. And then this is another thing to remember. This is the Nernst equation, and that's just the Nernst. Yeah. And then another thing to remember is anox and red cat. Anode, oxidation, and then reduction is cathode. And then that's really all we had to teach you about this chemistry lesson.
Well, guys, I still don't really get it.
Seriously?
Seriously.
Let's give it to him, boys. Ethnic rhymes up up in this class. Every time we rap, we kick some. The flow we spit about chemistry. Listen up as we create some imagery. Equilibrium, the ins and outs. Once I finish with this rap, you won't even have a doubt. Equilibrium expression KEQ. That's products of reactants and their orders too. KC is the constant for molar concentrations. KW for water, no miscommunications. KSP, constant without denominator. Trickier than Cali's Governor Arnold Schwarzenegger. Q is what we call the reaction quotient, determining direction. Q's always potent. Shout out to my boy LaShot Lie. His work with directions got me an easy A. That sums it up, equilibrium in a shell. Now for kinetics, don't leave until you hear the bell.
Yo, it's Big Dub, and I got chapter 13. Electrochemistry is a topic, and you might think it's hurting, but it's not. It doesn't make me want to stop. I just keep learning. Oxidation reduction, always end up on the test, so we about to study. Really give it our best before you start learning. There's some things you should remember. Oxidation number first, that's the first thing on the paper. Then you do your HAPR actions. Hope there are no fractions that would suck like LC parking lot pack-ins. When you looking for the agents to get all the credit. Leo says, "Grr, you don't even gotta check it." Getting kinda tired, don't got a galvanic cell. Wish I had a battery like the bunny from the commercial cell. Last thing to talk about, reduction potential. Not too hard, just a little bit mental. Adding two volts together, all of it simple. All I'm trying to do is chill and pass and get out of my final chemistry class.
Yo, chapter 12 is all about kinetics. When we do our experiment, you better call the medics. Kinetics is all rate, law, and order. While I'm doing these problems, hoping class gets shorter. So determine the rate law, it's easy to do. Simply take experiment 3 over experiment 2. Plug in the variables to find K. If you do it right, there's nothing left for me to say. I feel it's also important to know first order reactions have a negative slope. With second order, the slope is always positive. Now I've given you all I've ever had to give, but if you listen to Little Murph in class with a little of me, I'm sure you're gonna pass. That's all you have to hear, that's all we have to say. This is chemistry the ethnic rhymes way. So Cameron, do you understand?